Hello, this is Mr. Stansbury. I'm going to take you through the notes on two-column proofs. Okay. At the end of this, you should be able to say, I can use properties to complete algebraic two-column proofs. Okay, so first things first, let's look at all the algebraic properties. Okay, I'm going to walk you through what all of these mean. These are going to make a lot more sense once we see them in an example, but I'd still like to go through and at least explain them to you really quick. Reflexive property is for every number A has to equal A. Okay, symmetric properties, if A equals B, then B has to equal A. Transitive properties, if you have the numbers A, B, and C, if A equals B, and then B equals C, then A has to also equal C. Okay. For addition and subtraction properties, addition for all numbers A, B, and C, if A equals B, then we can add C to both sides and still make it equal. And also, if A equals B, we can subtract C from both sides to make it equal. Okay. Multiplication and division properties for all numbers A, B, and C, if A equals B, then A times C has to also equal B times C, and then also A divided by C has to equal B divided by C, just so long as C is not equal to 0, because we can't divide by 0. Okay. Substitution properties for all numbers A and B. If A equals B, then A can be replaced by B in any expression or equation. Okay, so you can substitute one in for the other. And then distributive properties for all numbers A, B, and C. A times the quantity B plus C is A times B plus A times C. Okay, those are all the properties. Let's take a look at these in an example, and this will make a little bit more sense. Okay, fill in each reason for the two-column proof. We have the given, which is 2 times the quantity x plus 5, and then minus 4 equals 6x plus 26. Prove that x equals negative 5. Okay, so pretty much all the time with these proofs here, we're going to pretty much always start with our given. Always, probably about 95%. With the algebraic proofs, it's pretty much all the time, but sometimes with geometric proofs, we've come up with some other stuff first. But anyway, on this one here, 2 times x plus 5 minus 4, 2 times x plus 5 minus 4 equals 6x plus 26. This here is given. And if you'll notice, that's really not an algebraic property. That's just something that they gave us at the beginning. So we're going to write given here. Okay, that's not an algebraic property. It's just given. This is what we're starting with. You have to start with something, right? So that's our given. Okay, now if you'll look, to get from here to here, all we're trying to do is figure out what did we do to both sides to get from the one step to, in this case, the second step. So if you'll notice, we got rid of the 4. How did we, the red negative 4. So how did we get rid of the negative 4? We added 4 to both sides. So 26 plus 4 is 30. Negative 4 and 4 is 0. So since we added two things to the same side, guess what? It's the addition property. Okay, so addition property. Okay, and then now from how do we get from, this is the same over here, 6x plus 30 equals 6x plus 30. Nothing changed over here, but this here, we took the 2 times x is 2x, 2 times 5 is 10. We distributed, so guess what? Distributive property. Okay. Okay, and then if you'll notice now the 2x went away. Right, and we got rid of 2x from over here. So how do we get rid of that 2x? We subtract 2x from both sides. Subtract 2x. And then that gives us this line here. So what did we do? We subtracted. So that would be the subtraction property. Okay. Let's see. The 10 turned into a negative 20. Oh, that's because we subtracted 30 from over here and subtracted 30 from over there. So we, again, subtracted. Subtraction property. Okay, and then let's see, from this step to that step we got rid of the 4. So right now the 4 is attached to the x with a multiplication, so to undo that multiplication we have to divide both sides by 4. So we divided both sides, so that's the division property. Okay, and then last step, we have to prove that x equals negative 5. Right now we have negative 5 equals x, so we have to switch those two things around. Okay, and that's this symmetric property up here. If A equals B, then B equals A. So if we're just switching the two things around on the, not really doing any kind of addition, subtraction, multiplication, or division, that's going to be our symmetric property. Okay, so that is this whole thing here. Hopefully that helps these make a little bit more sense. Okay, let's take a look at one more example and then away we go. Oops, let me get rid of that stuff. Okay, here we go. Complete the proof statement and write a 2-column proof for the equation given 4 times x minus 3 equals 2x minus 8. So basically what they're saying is solve this thing for x, and then we have to write our own proof statement. So what we want to do first is let's go through and let's solve this thing. So let's do this. This is do our statements and our reasons. Statements. And then over here we're going to do reasons. And do our little 2-column proof here. Okay. So first thing that we're going to do is we're going to start with 4 times x minus 3 equals 2x minus 8. How do we know that that's true? Because they gave it to us. It's given. So there's 2 things you could do with this. You can go through and just solve this whole thing and then go back and put all the reasons in, or you can solve and put the reasons in at the as you move along. I'm going to put the reasons in as we go. I think it'll help make a little bit more sense. So again, the reason why we have this here is that was given. So given. Okay, now we just say, okay, what do we want to do to both sides? Let's get rid of that one. We can give ourselves some room to work. So we can do a couple of different things here, and there's no either way is correct. We can either distribute this 4 through, or we could subtract the 8 from both sides. I think it's going to make more sense to distribute this 4 through and then start simplifying that way. So let's do that. 4 times, so if I distribute that through, 4 times x is 4x. 4 times negative 3 is negative 12. And that's going to equal 2x minus 8. Right? So what did we do to get from here to here? We used the distributive property. Okay? Next, now we've got x's on both sides and constants on both sides. Let's do this. I'm going to move the x's over here to keep these x's positive. That might save us a step. So I'm going to then subtract 2x from both sides. Okay? So 4x minus 2x is going to leave us with 2x, and we still have this negative 12. And then these 2x's are gone over here, and we now have negative 8. So this is what we end up with for our step 3. Okay? It's possible that you could actually do you could subtract, if this was like, say, a positive 12, we could subtract 12 from both sides at the same time, but it's really best to just do one step at a time, because that's going to, you really want to just do one thing at a time, and we'll just go through on the next step and get the next part on there. So again, to get from here to here, we subtracted from both sides. So step 3 is going to be subtraction property. Okay, next let's see, we've got the x's on one side. Let's move this 12 over. So we're going to have to add 12 to both sides. And we're left with 2x here. And then negative 8 and 12 gives us 4. So how did we do that? We added to both sides, so that would be the addition property. Okay, so now we're at 2x equals 4. Really the last thing we want to do here is divide both sides by 2, right? And we get that x equals 2. So how did we get from this step to that step? We divided. That's the division property. Okay? And we already have the x on the left side, so that's what we want. We always want to have the variable on the left side. So now our prove statement is prove that x equals 2. And we have we've made our own proof for this algebraic problem here. Okay, that's really all there is to the 2-column proofs using for algebraic 2-column proofs. So if you have any further questions at all on this, please feel free to ask in class. Thanks.